Just give me a minute. I will share my screen. So I will go from the first problem and we'll move sequentially. Okay. So after every problem, I will stop and ask you if you have anything specific to ask in the concept, and we can discuss and then move forward. All right. So the first question that we have here is the voice okay? Is it very low or something?
It is okay,
No,
ma'am.
ma'am. It's
Okay.
This
All
is
right.
fine.
Yeah. Okay. All right. So the first question that we have here is, let x and y be independent, exponentially distributed random variable. Okay. So we have the first information that we have is we have two random variables x and y, and they both are exponential distributed. X, y are both exponentially distributed, and each with expected value 1. So we know that if we have a random variable x with the distribution exponential, let's say the parameter is lambda. If you have a random variable x that follows the exponential distribution, then expectation of x is given by 1 upon lambda, correct? So here we have two random variables which are exponentially distributed, and they both have the expected value 1. So since the expected value of 1, the parameter is going to be just 1. All right. Then the second thing that we have to check is what is it that we have to find. So we have to find, so this is the information about the two random variables x and y. Now we have to find the probability that x is greater than y given x is less than 2y. Right? So this is a conditional probability. Right? Now, how will we write it? So it is going to be probability x is greater than y, x is less than 2y divided by, so joint divided by marginal. So the marginal is going to be, so in this case, this is your one event. Let's say this is one event A, this is another event B. Then probability of A intersection B divided by probability of B. So it is going to be probability x less than 2y. Now, whenever you come across the problem like this, the first thing you should do is to draw a support. Okay, so the first thing that you should do is to draw the support. Now, in case of exponential distribution, you know that the distribution like fx of x, distribution of x is given by lambda e to the power minus lambda x for x positive, correct? Now, let's draw the support. So if this is your x, this is your y. So the first thing is x is greater than y, and second is x is less than 2y. So we will draw x equals y. So this is your line x equals y, and we have to find the reason x is greater than y. So this is your, okay. So this reason is your, this is going to be x is greater than y. Now the second event is x is less than 2y. So now we will plot x equals 2y. So x equals 2y is going to be this line. So this line is x equals 2y. And we want this x to be less than 2y, right? So let's take some different color. So 2y should be greater than x. So it will cover all this reason above this line. All right. So this probability, that is probability that x is greater than y and x is less than 2y is, so we have to look for their common, like intersection of these two events, which is this reason, right? Basically this reason. So we have to do the integration over this reason, and in the denominator part you have x is less than 2y, that is this whole red reason, right? So first we'll find the numerator.
Ma'am, I have a doubt here. Like they are exponentially distributed, but you're drawing straight lines. So why you are not drawing exponential curve?
No. I am not. See, x and it is given that xy is exponentially distributed. That is 1, right? Like parameter 1. X and y are like individual x and individual y is this distribution, exponential distribution. Okay, and this is one event. X is greater than y. This is one event.
So they can be represented in a 2D space, something like that, away from the distribution. Okay.
Yeah, ma'am.
Yes.
Now it is mentioned this x and y are independent. So can we write the marginal, the product of marginal is joint?
Product of marginal is joint. Yes, right. We can do that.
So can we write probability of x greater than y into probability of x less than 2y?
No. See, x and y are independent. It is not given that x greater than y. Like these two are two different events. These two are two different events. One event A, another event is B. It is not given that the event A is independent of event B. It is given that x and y are independent.
So it may not be independent, right?
Yeah, these may not be independent.
Okay.
Now, okay. So in the numerator part, now we have to find, we'll first see the numerator part. Okay.
So, ma'am, can you tell me what is the limit? What is the like x lies between which interval? What is the interval for x?
Interval for x is 0 to infinity.
And y also?
Y also from 0 to infinity.
Okay, ma'am.
Like if you draw it individually, like x and y, if you say it as one, just x is exponential 1. So how do you draw the graph of x, like exponential distribution? So it is lambda e to the power minus lambda x. So lambda is given to be 1, correct? And okay, for x equals 0, it is going to be just lambda, correct?
So, ma'am, one thing I want to ask here. Ma'am, for the marginal of x, we write that lambda into e to the power minus lambda x, where x lies between 0 to 1. It can't be negative. So,
why it is saying x lies between 0 to 1?
Ma'am, x can't be negative in exponential, no?
No, but why 1? I'm asking.
Okay.
First, okay, let me finish this problem, then I will come back to your question.
Ma'am, it can go to infinity or not? I have confusion in this.
It can go to infinity.
Okay, ma'am.
Yeah. So first, let's see. First, we are calculating the numerator part. So how do you find it? It is just you have to integrate your fxy, dx dy over the support. Correct? Now this is your reason. This one. So what I will do is, can you mute yourself? So, all right. So what I will do is, I will take a vertical strip. Okay. So we don't know the distribution of like the joint distribution of fx xy, correct? But it is given that x and y are independent, right? So whenever x and y are independent, we can always write fxy as fx of x times fy of y. Is this fine?
Ma'am, sorry to interrupt. Just one small question triggered by this. This FX, the PDF functions and all, for the upcoming quiz, will we be given the formula sheet or?
The formula sheet is already provided on the portal. I have informed that also. So can you go and check?
Yeah, it's there on the portal, but I'm asking like during the quiz, do we have to mug it up or will it be given to us?
No, that formula file is given to you because that formula file you're going to get in the quiz too.
Okay, but can I just understand, get it in the sense, how do we are going to get it in quiz 2 in the sense, how will we get it?
You will
Same like mock, it will be visible.
Yes.
How many questions will be there in quiz?
Please, can you please not interrupt? Like, let me finish this and then we'll discuss. Okay.
Okay, ma'am.
All this extra question we can take later. So just go in sequence. All right. So we had to find this probability, and we can write our joint probability as the product of marginal, because x and y were independent. Now we know the distribution of x and distribution of y. That is given by lambda e to the power lambda x. So lambda in this case, so each of x and y is exponential 1. So lambda is going to be 1. So e to the power minus x, e to the power minus y, dx, dy, right? And how is the range varying? So let's say first I'm integrating with respect to y. First I'm integrating with respect to y. So I will treat my e to the power minus x as constant. So let's put it there. I'll put e to the power minus x there. And first I will integrate with respect to y. So if I make a vertical strip, you see your y is varying from x by
X.
to x.
X by
So
2.
x by 2.
Yeah.
X by 2 to x, and this is dx. So if I integrate this, you will get e to the power minus y, minus will come outside, so you will have e to the power minus x here, and the limit is going to be x by 2 to x.
Ma'am, sorry for interrupting. Without looking at graph, how can we determine the limits of y?
Without look, you will have to draw the support and check the limit.
There is no mathematical formula.
No, there is no such mathematical formula. Like, you have just two events and you will have to look their common intersection point, and only if you know their common intersection reason, you can identify like how to take the limit. So this is the very simplest way to take the limit. Like you, if you want first to integrate with respect to y, you like make a vertical strip and check the limit for y. Like how is y varying? So for the lower limit, you check the lower curve, and for the upper limit, you check the upper curve. And if you want to integrate first with respect to x, then you make a horizontal strip and check what is the, like how is x varying. So if you first take this part, right? So it is x is going to vary from y to like this curve.
Right.
Right. Okay. So we integrate this and we will get this as minus e to the power minus x, e to the power minus x minus e to the power minus x by 2. Now we will have to integrate with respect to x. So if you solve it, you will get, you can do the calculation. So it will minus 2x minus e to the power minus 3x by 2. And you have to integrate this with respect to x. Now, how is x varying? You have fixed the limit for y. Now, how is your x varying?
0 to infinity.
X is varying from 0 to infinity. So again, you just integrate with respect to x and then you can get your answer. So this is for the numerator part. For the denominator part, you have to find probability x less than 2y. Okay. So this is basically this reason, this red shaded reason here. So if you have to find this, again, we will proceed to the same. We'll do in double integral fxy dx dy. And here again, if we don't know the joint distribution, we'll use the independence condition and we will say it is product of marginal, and we'll go through the same method and just the limit will change. So if you do it, your y will vary from x to infinity and your x will vary from 0 to infinity.
Sorry, ma'am, how we found this 0 to infinity?
Yeah, okay. Second case, right?
Yeah.
I'll make this again. Sure.
Y will vary from x by 2 to infinity.
Just hold on. This is your y equals x. This is our x equals 2y. And we have to find this reason. So if I want to find this probability x less than 2y, then this is e to the power minus x, e to the power minus x, e to the power minus y, dy dx. Okay. So y is varying from x by 2. Sorry, I said I think wrong before. So your y is varying from x by 2. So y is varying from x by 2 to infinity, and x is varying from 0 to infinity. Right? Is this clear?
So earlier, like you said, like it is a intersection between like y equal to x and x equal to 2y, right? No,
Yes.
no, you're saying it goes, okay, because the region is much more. That understood. What about x equal to 0 and infinity? Can you explain that?
This part, right? X equals 0 to infinity.
Yeah, yeah.
So we have fixed our limit for y that goes from x by 2 to infinity. Correct? Now you have to take the limit for x. So this is this all orange shaded region is what your interest is. Now this is lying from where? This is going from your 0 to infinity. Like you have x greater than 0. This is the support of x. So your x is going from basically 0 to infinity. It can take any value there.
Got it.
Okay, so somebody has asked paper will be similar to mock quiz.
Ma'am, can I ask a question?
Yeah.
Ma'am, as per the given conditions, x is greater than y and x is also less than 2y.
Yeah.
So if we are going for x is less than 2y, it should be the area below the line of x equal to 2y. And for x greater than y, it should be the area above y equal to x.
No, right?
No, it's wrong. Yeah.
See, you want x greater than y, right? X greater than y. So this is your x equals y line, and you want x to be greater than y. So this is going to be this area. this represents x is greater than y. In this case, here you have x greater than y. And x less than 2y. So this is your line x equals 2y. And you want your 2y to be greater than x. So you should go to the y-axis side. So this is this orange shaded region.
Ma'am, is there any trick to find
your voice is very okay. Your voice is very breaking.
Except putting the values on the sides.
Can you mute yourself?
Hello, ma'am.
Yes, Harsh.
Is it okay, ma'am?
Now it is okay. Can you tell now?
Hello. Yes, ma'am.
Yes. Can you repeat now?
I'm audible?
Yeah, you're audible now.
Yeah, ma'am, I was asking, is there any trick to find out whether the area will be above the line or below the line, except the putting the values on that side?
Okay, so one simple thing that you can do is now you mute yourself. Okay. So one thing that you can do is like
ma'am, can we just integrate x equals y and subtract x equals 2y?
Sorry?
Can we integrate x equals y and subtract x equals 2y? Integration of x equals 2y.
Okay, for this problem, is it?
Yes, ma'am.
Okay, so if you do x stated, okay, if you find this, you had to wait. So you had to find this reason. So what you're saying is, this is x equals 2y, this is x equals y. So you are saying is, can you repeat?
We integrate the upper function, that is x equals y, and subtract the integration of x equals 2y. That is implying putting it into the PM formula.
What is your limit?
From 0 to infinity for both, because we are only differentiating with respect to 1. We can take x or y. We'll take dx, then we will represent all y in terms of x. For x equals y, e to the power minus x, e to the power minus x. It will become e to the power minus 2x. We integrate that. And minus the integral of e to the power minus x times e to the power minus x by 2.
What is your limit?
0 to infinity for both.
0 to infinity for both.
Both of them.
So you are saying first find this area, I mean this area.
Everything under that curve and subtract the lower.
Then find this area and subtract these two. This is what you're saying,
yes.
Right?
Subtract the first from the second. No, second from the first.
Yeah, I got it. So if we want to find this area, so you should have okay, effect, so e to the power minus x, e to the power minus y, dx dy, and your y is varying from 0 to x here, right? Y is varying
0 to x and 0
x
to x and
from 0 to infinity.
Yeah, and we need not even
then you did this thing, same thing, y varying from 0 to x by 2 and x varying from 0 to infinity, and then subtracted it, right? This is what you have done, right?
Yes, ma'am. And I also think double integration is not even that necessary for this, because the moment I know x equals y, I can directly put it into the joint PMF formula. fxy of x comma y will become e to the power minus 2x for x equals y.
No, you will have to, like, how will you find the area then? Like, this is, you are not in 2D now.
Without double integration, it is not possible, I think.
Ma'am, we can take this later, ma'am. Like we are already half an hour done and we are in first question.
Okay, ma'am.
Yeah,
It
all
was
right.
necessary.
Okay. Yeah. Okay. So there you have select 3 facts formula steps from the list of options that you will use for solving question 1. So what all things we have used here? So first thing is we should know what is the first thing is like what is the PDF of exponential distribution, right? So we have used fx of x is lambda e to the power minus lambda x. And we have also used the expectation of an exponential distribution, that is 1 upon lambda. Second thing that we have used is probability. If you have two events A and B, probability of A given B is given by probability of A intersection B divided by probability of B. We have also used this independence condition that says fx(y), if x and y are independent, you can write your fxy as fx times fy. So this is the third point. So these three we are definitely using. And anything else we can. So you can look at all the list of options that you have and you can select. Okay. So this thing we are using.
Ma'am, can you please give an example of method statement based on the formula sheet for the given problem what we resolved?
Method statement.
Yeah, because in the quiz they are asking about stepwise methods. So now we have a formula sheet, we have worked out a problem. Can we connect these two and write the methods? What are the steps we are using in this one? I'm just an example.
Okay, so yeah, like the way I calculated, I have used these informations and I have also used the integration formula for
yeah, how do we connect this? How do we connect this one to the formula sheet?
Okay. So like what generally I will do is like I do my problem and then I check in the formula sheet. So you have this list of options here. So I will see whether I have used we have to find the conditional probability, right? So I can see we have it in the formula list of options. So I can say I have used this for the first problem. Okay. Now I know that this nowhere we came across integral of x to the power n dx. So I will not use it. CLT is not valid there. All this is not valid there. Now I had to find I had some event and I had to find the probability of it. So how I did it is I double integrated the R joint distribution and over the support. So I know that I have used this. So I can mark this also as in the first problem. Now, if I look at the 10th option, of course, I haven't used it. 11th also, I haven't used it. 10th, 12th, again, this normal distribution. Now, if I look at this option, I know I have used this integration formula. So I can say I have used this for my first problem. Again, 14th, I know I have used it my first problem. Again, 16th, I know I have used it my first problem. So among all the steps, I can write any three I want.
Anything. You don't need to write all.
You don't need to write down all. Like if
but
the
they were telling about it chronologically. You need to write it. No, the increasing order of number.
Yeah, in increasing order, as in you have to like go with this. Like if you see the fourth first, you write fourth. If you see ninth, you write 9. You see 13, you write 13. Then 14, 16. Okay, even if you have written like more than 3, okay, but if anyone whatever you have written is wrong, you will lose your marks.
That is the point here. So if any of the formula which is not
even if you write just 2 steps and that is correct, you will get some partial mark. But if you write, let's say the question asked you to write just 3 steps and you have written, let's say 4-5 steps, but among those steps, if all were correct, you are okay. But if any of them is wrong, you will lose your marks. You will get
let's
zero.
assume that there are 4 correct formulas.
Okay, let's say I'm saying these
Hello,
are
ma'am.
correct.
Sorry for
here,
interrupting.
11th one is also the correct option, right? So we can use 11th also to solve the question.
11.
Hello, ma'am.
Yeah.
Sorry for interrupt. Can we discuss these things later? Actually, I have problem in question 1. So
even these are not graded, so you are just there, so you don't get any marks for attempting these.
So these questions are, I
All
think,
right,
not conceptual, no? That's why.
Okay.
Ma'am, for this diagram, right, x equal to y, the area under x equal to y will be half, because we are in, so an area under x equal to 2y will be 1/4. So the answer will be half minus 1/4, right? So it's a direct shortcut.
Yes, that is also right. Yeah.
Ma'am, hello.
Yes.
Ma'am, is it necessary to take integrations of y first?
No, it is not necessary.
Can we do
You said if it is
integrations
a
of
vertical strip, you got to do the y integration first, is it?
Subramanian sir, please let me finish the
Yep.
case.
Yeah. Okay.
Okay. Carry on.
Ma'am, is it necessary to integrate with
First,
y?
no, it is not necessary that you integrate first with respect to y and then with integrate with respect to x. You can do any way you find easier.
If we do integrate with respect to x first, so can we solve it?
Can you? Yeah, you can solve it. So what is your integration limit?
Integration would be x to infinity and y would be x by 2 to infinity. Is it?
Sorry, can you repeat again?
X is 0 to infinity and y would be x by 2 to infinity.
Y would be x by 2 to infinity. Your x will vary from y to 2y.
So if we do integration with respect to x, so we have to take the limit of x, right? And it
Yeah.
Okay. Yeah, it would be a y to 2y, right?
Yeah, just try it out. You can do it just now and we can discuss at the end. Okay, you can do it now and we'll discuss at the end. It's already like more than half an hour. Okay. So the second problem is that x is uniformly distributed over the interval -1 to 1. So you have -1 to 1 and we have a function y that is 4 minus x squared and we have to find the PDF of y. So okay, so if x equals -1, your y will be what? It is going to be 3. So for x equals -1, your y is going to be 3, and for x equals 1 also, your y is going to be 3. But for x equals 0, okay, for x equals 0, your y is going to be 4. So basically, your y here is lying between 3 to 4. Okay, y is lying between 3 to 4.
How is it?
You take any point there. Like let's say I am taking half. Let's take half. Okay, so if x equals half, what is y? What is y?
3.7.
3.7, right? It will again come in this range, 3 to 4. So any value you take between 0 to 1 or -1 to 0, it will always lie between 3 to 4. So like it's like 3 is the lower limit and y is the upper limit. So your y lies between 3 to 4. So you have -1, you have 1, and y is lying between 3 to 4. Now I have to find the PDF of y. So is it a monotonic function y?
No.
Yes, ma'am.
No.
No.
No, right?
No, it is not.
No.
Yeah. So what we'll do is, like, first for any y, so this is y. So for any y less than equal to 3. Sorry. Y less than equal to 3, your the probability is going to be 0. This Fy of y, that is probability y less than equal to y is going to be 0. So basically we have to find for whatever y is lying between 3 to 4. So for y lying between 3 to 4, we have Fy of y to be probability of y lying less than equal to y, and y is what? 4 minus x square. So y is 4 minus x square less than equal to y, and this we can write it as, so minus of x square less than equal to y minus 4. So if you take this out, it is going to be x square greater than equal to 4 minus 5, which is less than equal to under root of this. Right? Now, what is the distribution of x?
Minus 1 to 1 uniform.
X is uniform in minus 1 to 1.
1 to 1, yeah.
So what is fx of x? 1 upon b minus a. Right? So this is 1 upon 2. Yeah. I'll just erase all this and write the final step here.
No, I think it is the CDF. You have to differentiate.
Yeah, once you get the CDF, you will have to differentiate to get the PDF. Okay, if anybody has problem in this, we can solve it completely. Otherwise, we can leave it.
Please solve this. This is the problem. This problem.
All right. So we were looking for y less this, right? And we had got probability x square greater than equal to under root of 4 minus, sorry, this is 4 minus y. So we have two different cases here. One is x is greater than equal to 4 minus y, and for if x is negative, this is going to be probability x is less than equal to minus 4 minus y.
Why did we add it, ma'am?
Sorry?
Ma'am, it would be root over 4 minus y, right? Greater than equals to.
Can you repeat?
It should be root over 4 minus y in the first expression.
Sorry. This.
Yeah. The addition. This addition is only due to because the positive and negative side is added.
Yes, because you have two different cases here.
is there any other method by the integration so that we can achieve this?
By integration?
Some other method by integration to achieve this probability? We have not gone through any questions like that.
You must have seen all this when you were doing week 3 or week 4. You have seen all this.
Maybe x square we missed it.
It's like or.
The last.
Addition is like or.
Sorry?
Okay, it is or.
The addition is like or, right, man?
Yeah, addition is like
it is
or.
Like,
yeah.
Okay. It is or. Either this or that. Right. Okay.
Now you just have to use your the uniform distribution formula PDF. So x is uniform in -1 to 1. So in this case, x is greater than 4 minus y. So let's say if this is our 4 minus y and this is our minus of √4 minus y. So between these two, again, it is going to be what? This is going to be just 1 minus 4 minus y divided by 2, right?
It is in between. It will come x less than equal to minus √4 minus y will be less than -1 or in between that.
So I couldn't understand.
This value x less than equal to √4 minus y. There are two parts, x greater than 4 √4 minus y and x less than 4 minus y. 4
right.
minus less than 4 minus y will be less than -1 part of in between -1 and 1.
It will be between -1 to 1 because your y is lying between 3 to 4. So if you take the square under root of the square root part, it is going to be less than.
It is in the range. It will be in the range only -1. Yeah, okay. Thank you.
Yeah, now just use the distribution of x and find. We have already found fy of y, and then we can just differentiate it and go back to our PDF. Yeah, let's move a little faster. Yeah, okay. Okay, one question. Are you getting the notification sound in the background?
Yes, ma'am. Yes, ma'am. Someone sounded.
All right. So in the third problem, it says from past experience, it is known that the number of tickets purchased by a person standing in a line at the ticket window for a movie follows a distribution that is mean mu equals 2.1, standard deviation 2. So from the first statement, we just know that you have some there are people who are standing in a queue for the ticket, and the number of tickets they purchase follow a distribution. So let's say we have a random variable x that represents the number of tickets purchased by each of the person, and it follows some distribution which we don't know what distribution it is, where the expectation of x is given by 2.4 and standard deviation of x is given by 2. It says, suppose that few hours before the start of movie, there are 100 persons standing in the line to purchase tickets. So if only 250 tickets remain, what is the probability that all 100% will be able to purchase the tickets they desire? So it is given to us that 250 tickets are left. We have 250 tickets left, and there are some 100 people that are standing in a queue. We have to find the probability that what is the chance that all the people, all these 100 people will be able to purchase the whatever number of tickets they want to buy. Okay, so if I take each, we have 100 people, and if I take each of the person as, let's say, xi. Okay, so xi here is representing number of tickets purchased by the person I. Okay, so let's say the person I is purchasing some number of tickets. Person 2, x1 is number of tickets purchased by person 1, x2 represents number of tickets purchased by person 2, up to so on. So it will go to 100, and it will represent number of tickets purchased by person 100%. So if we add it all, so x1 up to x100, if we add all this, we will get the number of tickets purchased by all these people, right? So we have to find the probability that x1 to x100 is less than 250. Only in this case, all the tickets that they want to buy, they will be able to buy, right?
It's less than or equal to?
It is okay. Like you can also take less than equal to, no issue. So basically, like if only 100 tickets are left and they all are able to purchase, sorry, if only 250 tickets are left and they all are able to purchase, it means we have to find this probability. Now we know this sample is quite large, and we can approximate using the normal distribution. So we can use a CLT, right? Each of the x's, so each of the person, like each of the x's are going to be independent and identically distributed, because the expectation is also given to be 2.4 and standard deviation is going to be 2 here. So using CLT, what we can say is, so if I represent this using S, I can say that using CLT, this S minus n mu divided by under root of n sigma follows the normal 0, 1 distribution. So what is our n here? It is 100. What is the mu here? Mu is like expectation of each of the xi, and that is given to be 2.4. What is sigma? It is again standard deviation of each of the xi, that is 2. Now if we try to bring this about this form, this to this S minus n mu upon sigma under root n form, then we will have probability that this S minus 100 times 2.4, that is going to be 240, divided by 2 under root 100, that is 20. This is less than equal to 250. 250 minus 240, that is your 10. 10 by 20, that is 1 upon 2. Now we know that this is normal 0, 1. So we can write probability z less than equal to 1 by 2. And this is fz of 0.5. Now this is our final answer. But we can, this is an identity type question, so we cannot write this. So you can see that in the fz value, you have fz of 0.5. So you can directly write this as your answer here.
Ma'am, I didn't understand the first line here.
Okay.
So the sum of the all random variables, how it is less equal to 250?
Yeah, this line here. Look at this part. Suppose that few hours before the start of movie, there are 100 persons standing in the line to purchase tickets. If only 250 tickets remain, what is the probability that all 100 persons will be able to purchase the tickets they desire? So this is what we have to find. We have to find the probability that all those 100 people who are standing in the line to purchase the ticket will be able to buy whatever they want. But there is also a restriction that only 250 tickets are left now. So let's say if the person I is person 1 is let's say purchasing let's say 10 tickets, and all other let's say from x1 to x10 everyone is purchasing some 10 tickets, so 100 is done. And from x20 x11 to x100, if everybody wants to buy say 20 tickets, then they won't be able to buy, right? Because they have just 50 tickets left.
Yes, ma'am.
And if we are
Got it.
saying, you got it?
Yes, ma'am. It means the only 250 tickets.
Only
will
250
be,
tickets were there. So if
they will not
whatever
sell
number of
250 tickets,
tickets,
right?
yeah, so whatever number of tickets they have to buy, it should be less than 250, less than equal to 250.
Okay, got it.
Okay.
Thank you, ma'am.
All right. So again, the formula steps, you can see we are using CLT here. We are using CLT. Then we are also using the properties of expectation, like expect sum of x1 plus up to xn. We can write this as expectation of x1 plus up to expectation of xn. Also, okay. Some people can also write it differently. Depends on your step. We'll look at the option and then we'll decide. So
Leave this one, ma'am, because this is every question self we have to do, because in the exam also it is very tedious.
All right.
It will take some time. Every question will take some time.
Yeah, all right. So moving to the next problem. So this is a third problem.
One question related to this, ma'am. But in other questions we find fz of 0 comes 0.5 everywhere it is 0. But I do not correlate how to get fz of 0 is equal to 0.5.
Fz of 0 is 0.5.
Yeah.
Okay.
It is given also and
okay. So z is what? Z is normal 0, 1. Okay.
0, yeah.
So how do you plot this graph? So mean is centered at 0, and you have, this is called standard normal distribution, right?
Yeah.
So this is symmetric, like the area is symmetric to this 0. So whatever area is covered on this side,
same area
is going to cover on this side. Since the total area has to be 1, so each of the individual part is going to be 0.5. So if I ask you, if it is given fz of 0, what does it mean?
Okay, got it. Fz, yeah. Less than that, yeah.
Yeah.
Thank you. Confusion was there, yeah.
Okay. All right. So the next problem we have is we have two random variables here, x and y, that denote retailer's daily cost sell and daily cost and daily sale price, right? So x denote what is the cost like at which he had bought, and y denotes like what is the price at which he has sold. Now the probability density function of x and y is given to us. X and y is given, and it is also given that x and y are independent, and p denote the daily profit of the retailer. So we all know that the profit formula is selling price minus cost price. So the selling price here is denoted by the random variable y, and the cost price is denoted by x. So the profit is going to be just y minus x. So we can simply mark 2. Now in the second part, we have to find what is the probability that retailer's profit of a day.
Ma'am, one question here. It is assumed that retailer is getting only profits, no losses are there. Because it may be loss also, no?
But in the problem, it is not written, right?
It has been assumed. Yeah, only profit is being considered, right?
Because we have asked the profit.
Okay. Okay.
Now, here you have to find what is the probability that retailer's profit of a day is greater than 0. So you have to find what is the probability that retailer's profit. What is the profit? It is denoted by P and it is given by y minus x. So what is the probability that the profit is greater than 0? It means probability that y minus x is greater than 0. So this we can write as probability y greater than x. Now this is what we have to find. Again, we don't know what is, so this is your one event and you have to find this probability, and it will be given by double integral fxy dx dy over the support of this region. Now again, we don't know what is the joint distribution of x and y, but we do know the marginal distribution of x and y, and it is given that x and y are independent. So we can use the fact that fxy can be written as fx times fy dx dy. Again, you will do the integration. So what is fx given as? So fx is 1 by 2 e to the power minus x by 2. Fy is e to the power minus y. Right? This is dx and dy. Okay. Now we'll plot y is greater than x. So this is your y equals x. So y is greater than x is this reason. So if I'm integrating first with respect to x, so I will draw a horizontal strip, and your x, you can see that your x is varying from 0 to this y, right? So x is varying from 0 to y, and y is varying from this x to infinity. Okay, there's space. I will do it here.
The other way, right? X will vary from 0 to infinity, right?
Hold on. What did I write? X
X will vary from 0 to y, and y varies from x to infinite. That's what you said.
Okay. Okay.
It sounds
So,
right.
no, this is not right. So it is y minus x. Y is greater than x. E to the power minus x by 2 e to the power minus y dx dy, and x is varying from, so x is greater than 0, y is greater than 0. Okay, so x is varying from 0 to this y, right?
Yes.
And y is varying from 0 to infinity. There I went wrong. Y is going from 0 to infinity, right? Y is greater than 0. Y is greater than 0. So y is varying from 0 to infinity. Right? So if I integrate it, so y is 0 to infinity, and let's take this y term outside because first I'm integrating with respect to x. So e to the power minus x by 2
Hello,
is
ma'am.
going, yeah.
Ma'am, you are integrating y greater than x. So we
Y
are taking the
greater
value
than
y x to infinite, x to infinity.
First I'm integrating with respect to x. First I'm integrating what
So, ma'am,
I've written here.
integrating
Yeah,
with respect to x is 0 to infinite.
0 to x, right? Sorry, 0 to y.
0 to y. Sorry.
0 to y.
Yeah.
Ma'am, but in mock solution, it is given from 0 to infinity.
You are integrating y
Let
greater
me
than
check the
x.
solution. Wait.
Yeah.
There it is first. Okay, there they have first integrated with respect to y first. That is what I'm saying. That if okay, so I am first integrating with respect
You are
to
taking
x.
respect to x.
I
Okay.
am first integrating with respect to x. Okay, so this is e to the power minus x by 2. I'm integrating this dx dy, and I'm saying x is varying from 0 to y.
0 to y. Yeah.
Okay, and y
Yeah,
is varying from 0 to infinity.
Right.
Right.
Yeah,
Now,
same thing.
now if okay, let's say if I want to first integrate with respect to y, I will draw a vertical strip. Okay, and if you do it, say this, now y is varying from x to infinity.
Yeah.
Right, and the next x will vary from 0 to infinity.
Yeah.
So you should take care of like what is like the limit of integration. Like if you are integrating first with respect to x, like how should the limit vary?
This is critical. This is only critical thing to support, to decide the support.
Yes.
Ma'am, can you solve this like with limit x to y, x is equals to 0 to y and y 0 to infinity? Because I did it this way and I got 1 by 4. So I'm not sure if I was.
Okay, so if I first integrate this, what I will get is e to the power minus x by 2 minus 1 by 2 outside. I think we also had 1 minus 1 by 2 outside, 1 by 2, yeah. So that will get, so here you have. Sorry. This is 1 by 2 and this is minus 1 by 2. So it will be minus 2. Now the limit of x is 0 to y and dy e to the power minus y. So this is going to be minus 1 e to the power minus y and e to the power minus y by 2 minus e to the power 0, that is 1 dy. So I can write this as minus e to the power minus 3y by 2 minus e to the power minus y dy. All right. So if I integrate this, I will get e to the power, sorry. So this is e to the power minus 3y by 2 divided by minus 3 by 2. What was the limit?
Okay.
0 to
infinity.
0
to
to
infinity.
Minus e to the power minus y divided by minus y. So I can say plus y. 0 to infinity. So this will go minus 3 by 2. So minus 2 by 3. So e to the power minus infinity, something by infinity is going to be 0. So this term will get cancelled out. Again, e to the power 1 by e to the power y something by infinity is 0. So this term will be 0. So minus 0 minus. Now you put in place of y 0. So you will get e to the power 0 as 1.
Yeah.
Right? So you will get minus 2 by 3 plus 1. So 1 minus 2 by 3, it is 1 by 3. Correct?
Correct.
So minus 1 by 3 and plus 1. So what is the answer?
Plus. 1 by 3 is the answer.
1 by 3 is the answer?
Yeah.
Yes, ma'am.
Okay. Yeah. So this is right, no?
Maybe I made some mistakes. Thank you, ma'am.
Yeah. Okay. So always take care of the limit. Like if you are integrating first with respect to x, like make a horizontal strip parallel to x-axis. If you are integrating first with respect to y, make a vertical strip parallel to y-axis. Always take care in this mind. Like whenever you solve a problem of this
Ma'am,
kind, always do this.
Ma'am, can we say that the second integration that we do should be done like in for the entire support? May it be x or y?
Px of y. What do you mean by that?
Like the second integration will be done with the limit for the entire support, like whatever the support should like. Is it like that or?
I did not get your point.
Actually, I'm confused with this and the first one. Actually, the first question was similar, and for that the y limit was starting from x by 2 to infinity or
Okay. I will come back to these two problems again, and I will discuss again how we have taken the limit. Okay.
Yes,
That's because we have two lines there. Here only one line that differs the limits actually. That's what he's asking.
You have a bounded reason there. Yeah, I will come back to it. Okay.
Okay. Thank you.
A little bit confusing. So
we'll see again the support part, like how to
okay,
take
ma'am.
the
Okay,
limit.
ma'am. Okay.
All right. So this was quite easy. It says the height are normally distributed with mean mu and standard deviation 8 centimeter. So we know, let's say the random variable x represents the height of the adult female, and it is given to us that it is normally distributed with mean mu and standard deviation 8 centimeter. If 10% of the female adults have height greater than 180 centimeter, what is the value of mu? Now what information do we have here is that around 10% of the female adults have height greater than 180 centimeter. So if here the random variable x is representing the height of the adult female, and it is given that probability that x is greater than 180 is 10%, means 0.1. So how do we solve this? So x is given to be normally distributed. So we can convert this to the z part. So because if I do this, it is quite complicated to solve the PDF of the normal distribution. So we have a simpler approach where we convert our normal distribution to the standard normal and then we proceed. So how do we convert any random variable to the normal form? So we just subtract the mean and divide it by standard deviation, right? So again, here we have x that is normally distributed. So if I subtract its mean, that is mean mu, and divide by its standard deviation, that is 8, and the same thing if we do on the other side, that is 180 minus mu divided by 8 is 0.1, right? So I know this is now the normal distribution set, and this follows normal 0, 1. So I can write this as probability z greater than 180 minus mu upon 8, and that is 0.1. Now,
for the normal conversion, we do what? Y minus n mu upon under root n sigma. No?
You have here the normal distribution. X is normally distributed. So even if you like
for other distributions, we will do
this is an that is you are talking about CLT. We're not going to the CLT part.
Yeah. CLT is not required.
We have just one random variable here, and that is normally distributed. And we want, since it is very difficult to work with the original, like the PDF of the normal distribution, because the integration is very lengthy and tricky, complicated kind of thing. But we know there is a slightly simpler approach, that is by going through the standard normal distribution. So I can always convert this x, the random variable x, to its standard normal form by subtracting its mean and dividing by standard deviation. So if I do that, I am getting probability z greater than 180 minus mu divided by 8. Now, this is a random variable z, right? And this can be written as 1 minus probability z less than equal to 180 minus mu divided by 8, that is 0.1. Correct? So,
Yeah.
now this 1 will go other side, so it will become minus 0.9, and you have a negative sign here also. So I can write this as just probability z less than equal to 180 minus mu by 8 equals 0.9. Now what is this? This we can write it as the CDF f set of 180 minus mu divided by 8, that is 0.9. Now we can take this f set on the
Ma'am,
right
1
side.
minus fz of 180.
Why is it 1 minus f set?
No, already one has been subtracted.
I have already subtracted this one here.
The options have only 0.8 and 0.2.
I have
You don't have 0.9.
I have already subtracted one.
Okay, ma'am, got it. Yeah.
Yeah. So if I take this f set, or if I, let's say, if I multiply this f set inverse on both sides, if I multiply both sides by f set inverse, what will I get? F set inverse times f set, it is going to be just 180 minus mu by 8 equals f set inverse of 0.9, and this will go on the side, and your mu will become 180 minus 8 times f z inverse of 0.9. So this is a final answer, right?
It's not in the options.
Okay. This now, okay, there it is wrong, but on the portal it has been corrected, right?
Ma'am, maybe it has been corrected later because while solving the mock,
Yeah,
it was not there.
yeah, I think it has been corrected.
On the portal has been corrected now.
Yeah, on the portal it has been corrected. Yeah.
It has been corrected.
Ma'am, just a moment. Can you please scroll little down?
Okay.
Little down, ma'am. Down.
Okay.
Yeah, I just wanted to see the answer one more time. Thanks, ma'am. One second.
Yeah.
Hold on for a minute, please.
Okay, sure.
Ma'am, here can we use weak law of large numbers to solve this question?
Weak law of large number to solve this question, okay?
But we won't get the answer in terms of this f inverse, so that's the problem.
No, here there is no n. How we apply this?
So weak law of large number generally we use for finding the bound, right? That will not give you the exact value, correct? Here I want to find the value of mu.
Here parameters are also not available. N is not available. How to do that?
Is this done? Did you write it
Yeah,
down?
ma'am. Yeah, ma'am.
Not.
Ma'am, 1 minute, please, ma'am.
Yeah, okay. You can take a snapshot if you want.
Ma'am, what is next if you really want to solve it? Now you're going to get the fz inverse of 0.9 from the tables?
Okay, like if you have to calculate the exact value, then what you should do is, like, if you know how to look at the fz value, then you should look for what value of z you will get the probability 0.9.
The table, is it?
From the table. Like if you want like the exact value, then after this step you should look for like what value of z will give you 0.9. And then you will have to.
Let's assume that it is 0.85. So how do we really take the finally a new value?
Okay, so let's say my fz of 0.85 you said.
Yeah.
Let's say 0.85 is giving me 0.9. So fz of 180 minus mu divided by 8 is this. Now I will just compare the things that are inside the bracket. But what we are saying is this is equivalent to fz of 0.85. Right? So 180 minus mu divided by 8 is going to be 0.85, and you can just find out the value of mu from here.
That's fine. Okay.
The same thing we are doing again and again in week 7. This is what we are doing, right?
Are we going to multiply that one 2 because it is on one side value of the curve, no non-distribution curve? Or?
Sorry, what multiplication?
Finally, when we get the mu, should we need to really multiply it by 2 or just leave it as it is?
Why do you want to multiply by 2?
Because the curve area, the value what we get it is for only the half of the normal distribution curve. Is it?
No.
No.
Why is that? No.
No. Okay. Thank you.
Okay. All right. Now we have the estimation, parameter estimation part. So this problem we have to find, you have a discrete random variable x and the probability mass function is given to us, where theta lies between 0 to 1. Now I want to estimate this parameter theta. You have if you have a discrete distribution and you have a parameter which is unknown to you, you don't know what is the probability of x equals x, right? You just know there is a parameter theta that is equivalent to probability which is equivalent to probability x equal 1 is 1 minus theta square. So we have to estimate this parameter now. We have to estimate this parameter using the method of moment. So whenever we do that, so first thing is like we find the first moment. So what is the first moment? First moment is always the expectation, right? So first moment M1 is nothing but the expectation of x. So how do you find the expectation? We have x taking the value 1, 2, and 3. And the probability is 1 minus theta square. Probability that x taking the value 2 is 2 theta times 1 minus theta, and probability that x taking the value 3 is theta square. So in order to find the expectation, we do sum over x times fx of x over the whatever values x is taking. Okay, it's in the range. Now we just multiply it. So you will get 1 times 1 minus theta square plus 2 times, so it is going to be 4 theta 1 minus theta plus 3 theta square. Now you do this, like you solve this, you will get 1 plus theta square minus 2 theta plus 4 theta minus 4 theta square plus 3 theta square. So it will become like all this will get cancelled out and you will have just 2 theta plus 1. So I will say my first moment of x is 2 theta plus 1. Okay. So this is just the first moment of x. Now please mute. Yeah. Now we have few samples here. That is, we have observed few samples. That is 2, 2, 1, 3, 1, 3, 1, 1, 2, 2. And if we have these samples, like how do you find the estimate of theta? So we know that this should be equivalent to the expected value, right? So let's see, our one is appearing how many times? It is 1, 2, 3, and 4. So okay, instead of doing this, we can just do the find the expected value of
mean, right?
Sorry.
To take sample mean, right?
Yeah, that is what I was going to say. So we'll take just the mean expected value of this sample and we will equate this to our first moment of x. So we have total of 10 samples here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you find the sample mean here, so expected value of x bar, if you find the expectation, you will get 4, 5, 8, 9, 12, 13, 14, 15, 16, 17, 18. 18 by 10, that is 1.8. So this should be equivalent to 2 theta plus 1. So if I equate this 2 theta plus 1 to 1.8, you will get 2 theta equals 0.8 and this is 0.4. So this should be an answer. So this is the estimate for this sample using method of moment. So whenever you have to find the estimate of the parameter using the method of moment, you first thing that you will do is you will find the expected value and then equate this, like you find the first moment and then you equate it to the expected value and you will get your answer.
Another method we are doing, would you like to do?
Which other method?
Of finding individual probabilities of 2, 1, and 3. We can get like that also.
Likelihood method.
Probability of 2.
That we do in likelihood. We'll come to it also.
Ma'am, will we be asked for second, third moment and so on, or is it sufficient for us to only this?
Ma'am, regarding this, how to calculate if you're asked like kth moment? Like we have to integrate what function to get the kth moment?
Kth moment. Okay, so no, we won't ask you more than 2 moment basically.
Okay, ma'am. Thank you.
Yeah? We won't ask you all this in exam. Exam is going to be simple. Don't worry. It is quite simple.
Ma'am, like the first mock.
But generally, how will you find the kth moment? Like you will integrate what function?
Kth. Okay, so first moment is your how do you write this?
First moment is expectation of x.
Second moment is expectation of x squared. Okay.
Yes, ma'am. Third moment is 0. Fourth moment is 3 into variance raised to the power 4. So how will you how will you do this for the kth? What will the algorithm for kth?
So I think it is differentiation, right? K times.
Yeah, differentiation of what function?
Differentiating the moment generating function and putting the parameter lambda as 0 after differentiation.
Okay.
All right. Okay, now in the next problem you have again a random variable x that has a density function given by this expression, and you have observed some 10 samples here and you have to find the likelihood for the given sample. So whenever you know the samples, just go from the usual definition of what is the likelihood. So if you have some samples x1 to xn, then this likelihood is given by product of fx of xi given the parameter, right? So in this case, we have one parameter here, that is sigma. Let's write it here, data. So this fx, if you put x to be, you just substitute in place of mod x, you substitute these samples and you do the product. So you have 1/2 sigma e to the power minus mod 4. It is going to be minus 4, right, by sigma into 1/2 sigma. So I can just take this 10 times because it is going to, there are 10 samples, and this term is going to be e to the power minus, if you take minus 2, mod of minus 2 is going to be just 2. So again minus 2 by sigma. So anything you take it will come outside the mod, it will become positive, and we will have this minus outside. I can see this 4 minus 4 is occurring 2 times. So I can just write it as 8 by sigma, minus 8 by sigma. Then 2 is minus 2, 2, 1, 2, 3 times. So I can write minus 6 by sigma. Then we have 1 here, 1 and minus 1. So again, e to the power minus 2 by sigma. This is also done. Then we have 5, 3 and 6. So e to the power minus 5 by sigma, e to the power minus 3 by sigma, and e to the power minus 6 by sigma. So if we add all this, we'll get 1 upon likelihood function. Yeah. So 1 upon 2 sigma e to the power minus 30 upon sigma. So this is our likelihood function. Now, what is the maximum likelihood estimate? So to find the maximum likelihood estimate, we'll have to do the use the log on both the side and then differentiate and then find a sigma. So 1 by 2 to the power 10 is going to be constant. So we can just simply ignore it. And I can say that our L is proportional to 1 upon sigma to the power 10 e to the power minus 30 upon sigma. Now, if I take the log on both the side, it is going to be, so log of sigma to the power 10. So minus 10 of log sigma plus, so log of e to the minus 30 by sigma. So this is minus 30 by sigma. Now we have to differentiate this likelihood function with respect to sigma. So if I do that, you are going to get minus 10 by log sigma is just 1 by sigma, and this is going to be 30 upon sigma square. If I equate it to 0, you will get sigma to be, just 3, right? Yeah.
Right one, 3 is there.
So this is a answer. So the estimate for the likelihood estimate for a parameter sigma is going to be 3. So don't try to write very complicated expressions and then use exercise and then substitute. If you know the sample, directly substitute it into the your PDF function and then solve it. It will be much easier to do that. Okay. Suppose this problem was from tutorial. So, okay, so you have n IID sample x1 to xn that is coming from the Poisson lambda, and you have an estimator of lambda. We don't know what the lambda is. You have taken one estimate of lambda, let's say lambda hat, to be x1 plus up to xn divided by under root of n. And you have to check what is the bias of this estimator, right? So this lambda hat is an estimator of this lambda. Now, how do you find the bias of an estimator? Let's say if I have a parameter theta and we have an estimator that is theta hat of theta, then if I have to find the bias of this estimator, I find expected value of this estimator minus the parameter, and this comes out to be expected value of theta hat minus theta. So in this case, our parameter is lambda and estimator is lambda hat. So bias of lambda hat is going to be what? This is again we will have to do expected value of lambda hat minus lambda, right? So what is expected value of lambda hat? Lambda hat is x1 plus up to xn divided by root n minus lambda. So this root n is again constant, we can pull it out, and this is going to be 1 upon under root n expected value of x1 up to xn. And since this expectation follows the linear property, we can just write n times expected value of x
Lambda.
divided by root n. That is, of course, lambda minus lambda. So n lambda by root n. So this is lambda upon, sorry, under root of n lambda minus lambda, right? So this should be our answer. So whenever you have to find the bias, you have an, let's say you have some distribution and where the parameter is unknown to you. So you take there is some estimator for your parameter. Let's say that estimator is theta hat, and whenever you have to find the bias of that estimator, you do expected value of the estimator minus the parameter, and that comes out to be expected value theta hat minus theta. So whenever you have to check whether an estimator is biased or not, you check whether this is coming out to be 0 or not. So if it comes out to be 0, we say it is unbiased. If it is equals to 0, if it is not equal to 0, we say it is biased. Okay, so this is the main thing that you have to take, like, remember in bias. Now the next problem, is you have a fair coin that is being tossed n times, and you have to use weak law of large number to find the minimum number of tosses of a fair coin needed, so that probability that average number of head openings differ at most 0.02 from 0.5 is at least 0.95. So what does the weak law of numbers say? It says probability that your mod of x bar minus mu less than delta is, or if I say I take greater than delta, is less than equal to, yeah, please mute it, keep yourself muted for something. So this is variance of x bar upon delta square, and the other way to write it as probability that mod of x bar minus mu less than equal to delta is greater than equal to 1 minus variance of x bar upon delta square. Now, if I write this first expression, if I use this first expression, this is equivalent to, like, you have this, hold on a minute. Okay, so if I look at this is my first expression and this is my second expression. So if I look at the first expression, so it says you have a set of random variables, that is IID x1 to xn, and x bar is the sample mean, and mu is the mean for the distribution x. So in case of the first one, you are looking at these bounds here. You're finding the bound on this probability, and in the second case, you're finding a bound on this probability. So this is x bar is this one. Okay. Now look at the question. It says find the minimum number of tosses so that probability that average number of heads obtained differs at most 0.02 from 0.5. Okay. So what do you mean by at most 0.02?
Less than or equal to.
Yeah, this will use this formula, correct? So this difference is at most 0.02. So I will go through.
In the formula, and delta square is there in the weak law of large number.
Where?
Since the formula variance upon n delta square.
I couldn't understand.
Variance divided by n delta square.
No, okay. So what is, okay, see, if you have n samples here, let's say x1 to xn is, let's say IID x, okay, and expectation of x is given as mu, and variance of x is given by sigma square, right? Now, if I have to find the expected value of x bar, what is this? This is mu. What is variance of x bar? It is sigma square by n. Now, if I substitute variance of x bar to be sigma square by n here, what is the formula that you will get? You will get 1 minus variance of x bar, that is sigma square by n delta square. It's my fault. I should have written here expectation of x bar here also, if I was written in this form. Okay.
No, which formula is working on? This one, n delta square, no?
No, what I'm saying is both are same, no?
No, but here, ma'am, in the first x bar is given, then it should be n, either x minus mu should be there.
I'm not able to understand what you're saying.
Here is the formula, probability of mod of x bar minus mu.
Yes.
When x bar comes, then n comes into the picture, no? X
Yeah,
bar
of
means
course. Yeah, it comes in the picture.
then n delta square should be there. If x minus mu
See,
greater
wait,
than delta.
I will tell this one more time.
Yeah,
Then I will come. Then I will come to you again. Okay, not in between. So if I have, let's say, n samples, n IID samples that has the distribution x, and its expectation, and the expectation of x is given by mu, and variance of x is given by sigma square. So x bar, we know it is given by x1 plus x2 up to xn by n, and its expectation is mu, right? This is, we know, and variance of x bar is given by sigma square by n. So using weak law of large number, we know that your probability, that is mod of x bar minus expected value of x bar greater than delta, should be less than equal to variance of x bar upon delta square. Now, in place of expected value of x bar, I will substitute mu, and variance of x bar, I will substitute sigma square by n. Okay. So it becomes probability mod of x bar minus mu greater than delta is less than equal to sigma square by n delta square.
Okay, fine. Okay, got it.
Now, what I was saying is, if you look at the first expression, it gives you the bound on this tail reason, the bound on this reason, this probability. And if I look at the second expression, it gives me the bound on this this reason. So what I'm interested in this problem is this reason, because it says average number of heads obtained differs at most 0.02. There is something that is written as at most. So maximum it can go 0.02 from 0.5. And what is 0.5? 0.5 is actually the mean when you're tossing a fair coin. It is actually your mean, right? Like, okay, so if you're tossing a fair coin, like each of the exercise here represent a toss of a coin, and we are interested in number of heads. So each of the exercise here is Bernoulli, that takes the value 0, 1, and its expected value is 1 by 2 p, right? That is 1 by 2. So expected value of x bar will also come out to be 0.5, that is 1 by 2. So that is already given in the problem, that expected value of x bar is 0.5. Delta is given to you, that is 0.02, and this bound is also given to you, that is 0.95. So we have to just substitute over here. So we will write probability mod of x bar minus 0.5 greater than 0.02 less than equal to, what is sigma square? So sigma square is the variance, like when you toss a coin, what is like when you toss a fair coin, what is the expectation? It is p, that is 1 by 2. What is the variance? That is p times q, that is 1 by 4, right? So it becomes 1 by 4 n delta square, that is 0.02 square. Now this is according to weak law of large number, it should happen. And it is also given to us that this is at least 0.95. So this should be greater than or equal to 0.95. Now if I solve this expression, now you just have to solve this expression. So you have 1 upon 4n 0.02 whole square, which is greater than or equal to 0.95. So I will take this 9 on n on the other side, and I will get n to be less than or equal to 1 upon 4 times 0.02 whole square times 0.95. Sorry, I have made a mistake here. Yeah.
I think we should have used the first formula.
No. I have made a mistake here. This is what we want actually.
Yeah, 1 minus.
Yeah, this is less than or equal to, and here it is 1 minus. Then you will get the right answer. So yeah, this will also change.
How is variance 1 by 4?
How is variance 1 by 4? Okay, what is the experiment here? Tossing a coin.
Tossing a coin.
Right? So each of the xi, the expectation is, so if you toss a coin, what is the expected value?
0.5.
What is the variance?
It will be 0.5 into 0.5.
0.25. So 1.4 is what? 0.25.
Okay.
Right. Okay. Let me just write it again here. So using weak law of large number, this should have happened. And the question asks, like, this probability should be at least 0.95. So P should be at least 0.95. It means it should be greater than 0.95. Right? Now if I solve this, so 1 minus 1 upon 4n 0.02 whole square greater than or equal to 0.95. So you take this minus 1 here, so it becomes 0.05, and again you have a minus sign. So both side minus sign, we can change the inequality. So 0.02 whole square less than or equal to 0.05. Now if I take this n on the other side, so n becomes greater than or equal to 1 upon 4 times 0.02 whole square times 0.05. You solve it, you should get your n value.
Ma'am, just a second. Could you scroll up a little?
Yeah. Okay.
Yeah, here the one you've put in box, after you changed it to probability of, no, the second one, probability of x bar minus 0.5 given okay, the mod of that is less than equal to 0.02. So that should be greater than equal to 1 minus the thing, right?
Right. Yeah, right. Mistake. Yeah, thanks.
It should be greater than.
Yes. Yeah. Thank you so much. Rest everything is fine, right?
Yeah.
Okay.
Yes, sir.
Now the same problem, you have to do using CLT. So we will see how what is the answer we'll get. I think something
12,500.
500.
12500. Okay. So the same problem, if we solve using CLT, we will see we will need less number of sample as what we have found in the weak law of large number for the same result. So like it basically shows like why CLT gives a better approximation. All right. So if I want to solve this using CLT, so what does CLT says? It says probability. Okay, we have to find probability mod of x bar minus of mu, that is 0.5 was sorry less than equal to 0.02 is at least 0.95. Now first thing I will do is I will solve this part. So what is x bar? X bar is your x1 plus up to xn divided by n minus 0.5. This is less than equal to 0.02. So I take n on the side and I will get this probability okay, s minus 0.5 n divided by n 0.02. So using CLT, we know that this s minus n mu upon under root of n times sigma. So what is sigma? It is 0.25. So sigma that should resemble normal 0, 1. Now I can keep this root n here and I can send the other root n on the other side. So if I do that, like you can see we already have the mu here, we already have n here. We can just
Ma'am, sigma is 0.5. No?
Sigma is 0.5, ma'am.
Sigma is 0.5.
Standard deviation is
I
0.5.
was I was doing the variance, right. So, yeah, sorry. Yeah, it is 0.5, right. Yeah. So I can get one root in here and leave one root in here, and I can also multiply and divide by 0.5 here. So if you do this, you can see this becomes your z, right? So probability of mod z less than equal to the 0.02 divided by 0.5 root n is this. Now if I do the mod of z, so this becomes 2 times the probability. 2 times the probability that z is less than equal to 0.02 by 0.5 root n.
-1.
Sorry.
That will be whole thing -1, no, ma'am.
Whole thing -1. Where is it -1?
We take common, then when we expand this modulus z less than
Okay, what is 0.02 by 0.5?
0.04, I think.
Okay, just write 0.04. So z should be less than equal to 0.04 root n, and minus of z should be less than equal to 0.04 root n. basically z should be greater than equal to minus 0.04 root n. Okay, so your z is lying between minus 0.04 root n to 0.04 root n. Is this fine?
Yeah, this is correct.
Where were you saying it is minus 1? I couldn't understand that thing.
After that, it will come minus 1, ma'am. When
We take common, so it becomes.
Oh.
Then because the negative value is
Can you mute yourself? I was talking to somebody else. I was asking
Now
somebody
expand
else.
this.
Yeah.
We get fz of.
Okay, you were saying there, right?
Yes, ma'am.
I mean, this part 2 times probability is that less than equal to minus. Okay, leave that part. So we have to find the probability of this area. So how to do that? So we can use fz of 0.04 root n minus fz of minus 0.04 root n. So we know that fz of minus a. So this probability is same as this probability, right? And fz of my, if let's say this is your, let's say sum a minus a and this is your a. So fz of minus a can be given as 1 minus fz of a. Is it right? fz of minus a is given by 1 minus fz of a.
Yeah.
Yes, correct. So the same thing we can apply it here, and for this term I can write fz of 0.04 root n minus fz of minus a, that is 1 minus fz of 0.04 root n, right? So this will be plus. So basically this is 2 times fz of 0.04 root n minus 1. And what is this it equal to? We were calculating this part, right? So we were calculating probability that mod of x minus of 0.5 less than equal to 0.02 is same as 2 times fz of 0.04 root n minus 1, and we have to find this greater than equal to 0.95, greater than equal to 0.95. So once you solve it, you can get the value of n. So you will see that the value of n is very small as compared to what you had found in the previous problem. Is that all right?
Yeah, ma'am.
Okay.
I think it's 2401.
1004 yeah, and the previous one we had 12500. So in this case we need a smaller sample to get the same result.
So ma'am, here we have to basically do that 0.04 into root n is since it's greater than we are given 0.95, right? So we have to equate that 0.04 into root n to be 1.96. Right, because the fz value of that.
Yes.
Okay. And ma'am, just to confirm, that's what you were mentioning at the start, right? When I asked that there's the list of options and the fz value. So you were referring to that as the formulas given, right?
List of Which formula? The one that is provided on the top?
Yeah, no, somebody said that on the, just like how it was in the mock exam, you will be given the formula sheet. So I just wanted to know, like, I'm not able to access any formula sheet. Even last time I tried, even for this mock, I'm not able to. Are you referring to the list of options as that formula?
No. So this list of options that you see here, those are for this 0 marks questions, like step marks question, right?
Yes.
And the formula file will also be there on the portal. Like we have already provided the formula file on the portal. Okay. The same formula file you will get in your quiz during the examination.
Okay.
It will be on the first page.
Okay, ma'am.
So
Okay.
you can just go to that formula file in case to see like what all formula has been already provided, so that you don't have to remember it.
Okay. So for the mock, we we could have just used what is shared on Drive, right?
Drive, yes.
Okay. I thought there's already a link in the mock portal, so I was not able to access.
No, it is not there. Yeah.
Okay, ma'am. And ma'am, just one question regarding that, the list of options. You see in the mock exam, they've given for the 0 mark question, select 3 facts.
Yes.
So though I thought there were 5 options which I used, but I wrote only 3, and now it's giving us like a wrong answer. And
no, on the portal, yes, on the portal it will give you 0 marks because it has been given as 0 marks. It is configured like that. So when it comes to the quiz, you must have seen in the quiz one. So you have to select 3 options, and those 3 options should be right. It is possible that there may be more than 3 correct options for that particular question. So if you write any wrong, you will get 0. But even if you, let's say, if we have asked you to write 3 steps, and if you have written 3 steps or 4 steps, but one is wrong, so you will lose marks. But if you wrote just 2, let's say, you will get some partial marks. So let's say if for those 0 marks question, if we have given let's say 2 marks,
okay,
and if you have written out of 3, you have written 2 correct, they'll give you the partial mark there.
Ma'am, order of these.
Order will matter. Like order should be correct.
Thank you.
Okay, so suppose there are actually 5 options which I've used. I have to just and if the question says select the 3 facts, then I have to, in ascending order, just write the first 3. I don't have to write all the 5.
No, you don't have to write all the 5. You write any 3 in ascending order.
Okay, any 3 in ascending order. Okay, any 3 out of the 5 I used in ascending order. Fine.
Ma'am, to solve this one, we will need FC inverse, right?
Yeah.
Value
So
of
FC inverse value has been given on the top.
So it is FC, right? Or if it is FC inverse.
Yeah. Okay. So I will solve this problem for you. So I think you're confused here.
Yeah, ma'am, here actually on top it's given FZ of 1.64 is 0.95. That's a typo only, right? We have to take 1.96 only here. Because I mean, in
this value is not
where
given.
is it given? That is not given actually.
No, here it's given FZ of 1.64 is 0.95.
Yes.
Yeah, but like I remember when we learned the the intervals.
Confidence interval.
Yeah, so there we were given, right, that FZ of 1.96 is 0.95.
That's different in different week. It's not related to this.
No. This value will be constant. So FC of 1.96.
That's only 0.95, right? FZ of 1.64 is 0.9.
0.9 is it? FC
No,
of...
sir gave in the 10th week, which is different from the normal calculator. That's what she's. The 3 values he specifically gave.
No, I'm talking about the confidence intervals. When we were given beta is a 0.95.
No, these values. See, these values are like fixed. Let me just check once. Just give me a minute. I'm sure this is the right
These
one.
values does not match with the internet values.
Just hold on a minute.
Yes, ma'am.
Let's confirm. So for 1.64 it is given, right? So 1.64 is yeah, 1.64 is 0.95. It is right. This is right. FC of 1.64 is 0.95. FC of minus 1.64 comes out to be 0.05. FC of 1.96 I guess comes out to be 0.975. Yeah, and FC of minus 1.96 comes out to be 0.025. These are the values that are frequently used. Just
Is it necessary
check.
to remember it? Remember it, ma'am?
Huh?
Is it necessary to remember these values?
No,
Frequently used.
you don't have to remember, but if you know, it's useful. So I will go
I
back.
got it, ma'am. So we need to replace 0.95 with FZ of 1.64. I didn't see this value. Thank you.
Okay, fine. Now the last part we have is for the MGF. Okay. So we have two random variables x1, x2, and they are IID x. And that follows the distribution as this one. Probability x equals k is this. Now we have to find the moment generating function of x. So from there we can say that x is taking the values minus 4, 1, 2, and some other values. Okay, and fx is correspondingly 0.3, 0.2, 0.5, and rest are 0. So we know that for the moment generating function, like it gives a unique distribution. Like if mx of lambda is written in this form, so this the moment generating this this term will give you like what all values your x is taking and what is the probability of each of those values. So if I look at the first mx of lambda, it says your x is taking the value minus 3, minus 4 with probability 0.3. So that matches with the first case, right? First value that it takes. Second is x is taking the value 2 with probability 0.2. That is wrong because x is taking the value 2 with probability 0.5. So I can discard this option. Second one, this was right. And x is taking the value 1 here with probability 0.2. So that is right. And x is taking the value 2 with probability 0.5. So I can see that this is the correct answer. So given a distribution, you can find the moment generating function and it is unique. So you just have to like write fx of x. So fx of minus 4 times e to the power minus x of, so minus x of lambda, that is in this case is minus of 4 is minus 4 and this is also minus 4. Okay, plus fx of 1 e to the power minus of e to the power lambda of x, right? So lambda is just x is 1, so 1 times lambda. Similar, just you write this expression and then substitute the values. You will get the MGF of the random variable. Now in the second problem, you have to find the distribution of y, where y is defined as x1 plus x2. So again, finding the MGF, we can find the distribution. So I will go with the MGF form. So if I find moment generating function, my of lambda, that is going to be expected value of e to the power lambda x. So in this case, the random variable is y, so it is going to be lambda y. Now what is your y? Y is x1 plus x2. So it is expected value of e to the power lambda x1 plus x2. Right? So this we can write as expected value of e to the power lambda x1 into e to the power lambda x2. Since these are independent, we can write expected value of e to the power lambda x1 into expected value of e to the power lambda x2. And x1 and x2 are IIDx. So their expected value is going to be same. So I can just write expected value of e to the power x lambda x whole square. We know the and this is what? This is mjf of x mx of lambda whole square. Right? We know what is the mjf of x. If we square it, we can find the distribution of y. Is it clear?
Yeah, yes, ma'am.
Okay, so we are done with all the problems. So number of questions that you see here, it's going to be almost the same.
Ma'am, actually, if you have a minute, can you please actually just complete this one, ma'am?
Okay.
So it is E of lambda the whole.
All right.
MX.
So what is mx of lambda? So mx of lambda we found to be 0.3 e to the power minus 4 lambda plus 0.2 e to the power lambda plus 0.5 e to the power 2 lambda.
2 lambda, that is the whole square.
Whole square, right? So what is the formula of a plus b plus c whole square? It is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. We'll use the same one. So a square is 0.09 e to the power minus 8 lambda plus 0.04 e to the power 2 lambda plus 0.25 e to the power 4 lambda plus 2ab. So 0.3 into 0.2, that is 0.06 into 2. So that is 0.12 e to the power minus 3 lambda plus 2 times 5 to 10. So 0.10, 0.20. So 0.20 e to the power 3 lambda plus 2 times 0.5, 15.30, 0.30 e to the power minus 2 lambda. So I can see that now y is taking the value minus 8, y is taking the value minus 8, 2, 4, minus 3, 3, and minus 2. And the probabilities corresponding to all these values are 0.09. For 2 it is 0.04.
0.25. I think it is A.
It is A, is it? 0.04, 0.25, 0.12, 0. Yes, it is A.
Okay. Okay, ma'am. Okay. Yeah, now I am getting it. Thank you, ma'am.
Okay, thank you. All right, so all the problems are done. We can just once look at how to take the reason of integration. Okay?
And question number 2, ma'am, was how to get this PDF also. I was having confusion.
Question number 2, okay.
2, PDF, how to get the PDF.
Okay, PDF, you can just differentiate it. So,
Is a standard method to get the PDF of any given 2 discrete and one
so standard
function.
method, okay, standard method was like if you knew that the function of, let's say, y equals fx. If this is monotonic in the support of x, then we have a standard method that you know that is given by fy of y is fx of g inverse of y divided by mod of g dash of g inverse of y. This is a standard formula that you know, right?
Okay.
But if it is not known to you, you will have to go through the usual method.
Okay. If it is not monotonic, then customized method.
Yes, yes.
Okay. And for customized method, what other steps we should follow?
You first find the CDF, find the you first first find the support of y, and then try to find the CDF of y, and then differentiate it and get the PDF. You can for if you want more practice on this part, you can pick out some problem from week 4 where this part has been done and try to solve it. I think it has been a long time, and
Okay.
yeah.
That's a list. Okay.
So
Okay.
yeah, but for exam, please just like mostly it's going to be your week 6, 7, 8. So study
5,
this
7, 8.
properly, and from there will be problem from previous week, but even if you don't know, it's okay. It's fine.
Okay.
Can you mute? Okay, so if anybody has doubt, they can stay back. Otherwise, you can leave.
We don't have confidence intervals problems, right?
No confidence interval.
Oh, thank you.
Ma'am, what do you mean by previous weeks for week 1 to 5?
Previous week 1 to 4. I'm saying like most of the questions are going to come from week 5, 7, and 8. So if you do these 3 chapters properly, you can score very well. So even if you don't know the previous concept, I'm saying it's fine. You will not lose a lot of marks there.
What kind of problem we expect to come from week 1 to 4? Because
That I cannot tell you.
What is not required to take one in this 5, 7, and 8 also, because the last session sir told that this after in chapter 8 estimation will not come like that, confidence interval will not come like that. Is it so, or that will be also covered in the question?
Yeah, from week 8, don't look at the confidence interval part.
Okay. Okay. You can leave it. Okay.
Confidence interval, you can just leave from week 8. It's fine.
Ma'am, actually, I have joined it, but there is a total 19 questions on the mock test, and your document has only 15.
Yeah, because this step, okay, some like look at this problem 4 and 5. So, okay. This is because this 0 marks question has not been added here. This is the reason. So if you add this 4, you will get 19.
Ma'am, can you share that question have 2 function fx and fy, and we find a joint function?
Yeah.
Please show that question one.
Okay. This one.
Yeah, please scroll down side.
Okay.
Thank you, ma'am.
Okay.
So can I leave, ma'am?
Yeah, you can leave. So
thank you very much, ma'am.
Yeah, thank you. So if you have no doubt, you can just leave, and if you have anything to ask, you can stay back.
Thank you, ma'am. It was a nice session.
Thank you. Yeah. All the best for your exam.
Thanks a lot, ma'am. Please do not make the questions like quiz one.
The paper is already prepared.
Okay.
Yeah.
For this quiz,
Ma'am, it will be like similar to mock 2, right? Somewhat level of difficulty or something.
Level of difficulty, I would say, yeah, more or less, almost same.
Concept 2, right, ma'am? Which will cover in mock 2, that will cover in quiz 2. That's it, right?
The concept, maybe there's something that is not there and something that is there. It is possible that some topics are there and there, but I cannot say it is exactly the same, but do what even sir has taken the session last time on Monday. Do the problems there, do it properly.
Okay, ma'am.
Do mock.
Hmm.
Like what I always suggest is like from each of the chapter you pick out important topics and try to uh, from all those topics you pick one problem and try to see if you are able to solve it or not, because it's mostly calculation part, and if you know the method and if you do it right, if you use it right and during the exam, it is there's a high chance you will get the answer right. Just know the method properly.
Yeah, for this session,
Yeah, ma'am.
for this session, are we going to get a structured document like how it has been solved, or will it be like this?
For which session?
This particular mock solution.
Mock solution. Okay, I didn't understand. You are asking about this document, what I have just discussed.
Yeah, what has been done today?
Huh?
Will there be a structured document like question answer kind of?
It is already provided. The solution already provided on the portal.
Oh, I have not seen that. Sorry about that.
It is there on the portal. You can check.
Okay, thank you so much.
Yeah.
Nikita, just 1 second. The screen which you're probably sharing, I want to know the support is confusing. You said in the earlier time, if you take y first, the limit differs, right? Just once more about only the limit.
This problem?
Yes, yes.
Yeah, okay. I will do that.
Can I ask one question?
After this, please.
Okay.
So I will do it again. This is first x and then y. If I have space, okay, I will do it again. So you had to find probability y minus x greater than 0. Okay. Now, what is my y? So this we can write as y is greater than x, and this kind is y equals x, and this is my y greater than x. Right. Now, I want to integrate this. So if I want to find this probability, so y greater than x is one event, and I want to find this probability, that is fx of y. You want me to first integrate with respect to y, so I will do it.
No, just the limits, how to take the support, that's all.
Okay, fine. So fx and fy, right? So if I want to integrate first with respect to y, so I will draw a vertical strip parallel to the y-axis. So you can see that this is the curve that y equals x, right? It is touching this curve, the strip, and y is varying from this x. Y is varying from x, and it goes till infinity.
Yeah.
Correct. Now, why it goes till infinity is because you look at fx and fy. X is greater than 0 and y is greater than 0. There is no other bound axis. So y is varying from x to infinity. So we have already fixed our y first. Now, if I want to find the limit of x, you see x is greater than 0. So the horizontal strip. So x is varying from basically 0 to infinity. X is greater than 0. We have already fixed our y first. So in the second integral, you just have to put the values. So check the upper limit, check the lower limit, and just put it there. So the lower limit in this case is going to be 0, and the upper limit for the x that can go is infinity. So I will just write x is going from 0 to infinity.
Okay, but if you change that first x, then next, then the same thing will reverse, right?
Yeah. So if I change this to like first x, then I draw the horizontal strip and I write x is varying now from 0 to y, and y is varying from 0 to infinity. That's right.
But if it is bounded like the first one,
okay,
then it won't change, I think, right?
Wait.
Be the same, right? However you take.
Let me see. So I had x equals y and I had x equals 2y and I had this reason. Now these two curve I have and I have this reason. So if I want to integrate first with respect to y, so y is varying from x by 2 to x, and x is varying from y is varying from x by 2, right? Y is varying from x by 2 to x, correct?
X by 2 to x.
And x is varying from 0 to infinity. Fine. Now, if I want to take, like integrate first with respect to x, I draw the horizontal strip, and I see this x is varying from this curve, that is y to 2y.
Yeah.
And y is varying from where? Y is varying from this 0 to infinity. Right?
But here
the lower limit of y is 0, and the upper maximum it can go is till infinity. So y is varying from 0 to infinity. Okay.
So it is always like second, whatever we did, differentiate, will it be a 0 to infinity or become?
Yeah, so what you have to keep in mind is you have the reason, and if you have to integrate first with respect to x, so in this case, let's say if I want to integrate first with respect to x, I drew a horizontal strip and I see like where is this strip touching the curve. So first is x equal y, at x equal y it is like, and x equals 2y. So the lower limit I will take is x equal y, and upper limit I will take is x equal to y, because these are the extreme, these are the curve that this strip is passing through, right? Now once I fix my x, now I will have to check the limit for y. So whenever you have to take the limit for the other variable, you look for the lower limit and then look for the upper limit that it can take. So the lower possible value that y could have taken here is 0, and the maximum that it would have taken is infinity. So I will take my y is varying from 0 to infinity. Second limit is just do this, like put the lower, like the least value that is take and the maximum value.
Depending on the given condition, right?
Condition, yeah, of course. Okay.
Ma'am, that method statement, no, that formulas.
The formulas.
Yeah. No. What I'm asking is, if you simply do not attempt that particular part of the question, will we lose anything? Because there is a risk of choosing a wrong answer, losing the every mark, no?
Oh, yes. So those are just 0 marks question. Yeah. So if you, what I will suggest is, like, if you are confident that this is what you have done is right, then do not attempt it.
Okay,
because
that's fine.
If not, you will spend at least a minute or two in solving that, like selecting the options.
Alternatively, if you're damn sure, then
If you
just
have,
pick one answer.
yeah, if you don't know, if you just know how to do it, but you have no idea how to calculate and you're unsure, your calculation is wrong, then it is a safe way to get some partial mark for that problem.
Okay, thank you.
So if you have time, please do it. It will help you in scoring more.
Okay, thank you, ma'am.
Yeah, thank you.
Okay, thank you very much. Good night.
Yeah, thank you. All the best.
Okay.
Anything else?
Ma'am,
Yes.
one question. Yeah.
Yeah.
I was asking in the chapter 7.7 in the lecture. Alpha, beta, gamma is also been covered, but there is no question in the mock also. Nothing has been covered here. So the question will be asked or not?
What alpha, beta, gamma?
Functions are there. Alpha, beta, gamma function has been covered in 7.7 in the lecture.
What is in 7.7? I think it is CLT, right?
7.7 is properties of.
7.7 is distribution properties and connections.
Distribution properties, yeah. Distribution properties and connections.
Okay.
But there is no question covered here. Whether it will be asked or not, we should go through that, not because time is very less. We should filter out.
Okay, so in the formula file, we already know it is already given to you. Like you have, let's say if you have the beta distribution, what is the PDF, what is the expectation, what is the variance. If you have a gamma distribution, what is
In
the
formula
PDF.
also, gamma function has not been given for us.
Sorry, function is given, right? PDF is given to you.
Yeah, in gamma,
PDF is given to you. So
a question may be asked out of that, right?
I don't think there are problems in that chapter. There are.
Okay. One question, they have a problem in graded assignment already, it has been solved. May I ask here?
If you need the formula like you check the
No,
formula.
Formula I have.
You should know the
because-
method. Any distribution come, you should be able to answer it. You should know the method how to do a certain kind of problem. You should know how to use CLT. You should know how to like solve the
CLT is okay, no. The function covered in the like gamma function, beta function, chi function. This function will be asked in the examination or not. This is my question.
I cannot tell you that.
Okay, that's it. Okay. The question number 2 in the graded assignment 5, can I ask some points? 1 or 2 lines is there, which is confusing. Already solution is there.
Okay, let me just see.
Question number 2, graded assignment 5.
Question number 2, graded assignment 5. Yeah. Y equals x z plus x is uniform in 1, 2, 3. That is, okay, what is the doubt?
The only thing I want to ask here is y is equal to xz plus x.
Y
It
equals
has
x
been
z.
plus x. It has been converted to the normal, different normal. And how to convert this transformation? Yeah.
How to convert what?
Variance becomes a square of that multiplied by the variance of the original distribution. But what about this mu? This is also multiplied by the factors.
Okay, can wait, I will share my screen and then you can tell me where is the doubt.
Okay, please. Only conversion, scaling part is making confusion. Audible?
Wait.
Okay.
Yeah, tell me.
Yeah, here on the first line, conversion part.
This y given x.
Yeah.
Okay, what is the doubt here?
So how to convert this from this
Okay,
the normal is 1.
Okay. See, you had to find the distribution of y given x, right? Now x is taking the value, we know it is 1, 2, 3. Okay.
Yes.
So given x equals 1, so if you put x equals 1 here, so y given x equals 1 is going to be z plus 1. Huh?
Yeah.
And now z is what? Z is normal 1, 4.
4. Means 1 is mu and 4 is the sigma.
Yeah. So you are just translating your this distribution by 1.
Hello. How to translate this exactly?
So, okay, I will write it there. Can you mute? I can hear some.
Okay.
All right. So, You have, let's say, a random variable x that is, let's say, normal mu sigma square. Now you multiply this with the constant x and translate it by p. So this distribution also becomes normal with some expectation and some variance. Now, how do we find the expectation and variance? So expectation of x is what? It is going to be a times expected value of x, that is a times mu plus b. Now, what is the variance of x plus b? It is going to be a square times variance of x, right? So a square times sigma square. So same thing there we are doing. So given x equals 1, the distribution of x is z plus 1. And z was given to be some z was some normal distribution with some mean that is 1 and variance that is 4, right? So using the same property, this one, we can write this is again a normal distribution with mean a mu plus b. So what is a? A is just 1 here, right? So a times mu is what? 1 plus 1, that is 2, comma a square sigma square. So a square is 1, sigma square is again 4. So the distribution is normal too.
Got it, ma'am. Got it. Confusion was there.
Okay.
Got
Okay.
it.
Okay.
Thank you. Thank you.
Yeah.
Thank you. Thank you very much. Good night.
Yeah. Good night. Okay. So can we close the session now? Anything else?
Ma'am,
Yes. Yes, tell.
I just wanted to ask that if we study certain topics like 2D random continuous random variables, weak law of large numbers, CLT, method of moments, and ML. So will it be enough for quiz 2?
Yeah, I will say you can, if you practice it, you can pass first.
Yes, ma'am. With practice only that.
Yeah.
Because I'm a college student and we are also having exams in our college.
Yes, I can understand. So, yeah, if you study this much and do it properly, I think you can score well. You can at least pass. But try to like, I think most of the time the calculation goes wrong or something. But like, if what you should do is like, if you look at the paper, you know this topic, then attempt it. If you think you have some doubt, leave it for something. Do first whatever you know properly, and try to at least pass the like first. Okay?
But this gives a preparation for the end sum, no?
Yeah, of course, this gives the preparation.
The end sum has a higher weightage, is that ma'am?
NSIM has the higher weightage. Yeah.
Yeah. So obviously, any effort what we are putting on this
You're
one.
putting now is of course going to help for
End sum.
NSIM. Yeah.
That should be a good incentive for anybody.
Yeah.
Thank you, ma'am.
Yeah. Thank you. Anything else? So all the best, all of you, for the exam. You have one more day, study properly and do well in the exam. Okay?
Yeah, ma'am. Thank you, ma'am.
Yeah, thank you. We'll close the session now.